Okay, we're going to look at this problem in a couple different ways. You're asked to write the equation of a parabola just given the focus and the directrix. Okay, and it turns out these are all possible equations. This one's written in function notation. Now, this is written in standard form. One way to get there directly is to understand that HK is the vertex, so this is in vertex form, but the coefficient in front of the x minus h, the quantity squared, is 1 over 4p, where p is the directed distance from the vertex to the focus. And the vertex, first of all, the axis of symmetry is always perpendicular to the directrix. And the vertex lies on the axis of symmetry, and it's the midpoint of this segment. And this point has coordinates -6, 9. And this focus has coordinates -6, -7. So the midpoint is at -6, while the average of the y coordinates is 2 divided by 2, or 1. So there's the vertex, -6, 1. And the focus is always, quote, in the interior of the parabola. So the parabola has to open downward. And so what we mean by directed distance is from the vertex towards the focus is in the negative direction. So the distance from 1 to -7 is 8, but the directed distance is -8. So in our case, P equals -8. We've got the vertex at -6, 1. On the next board, I've actually substituted into this formula right over here. P is -8. H is -6, so x minus a -6 is +6. K is 1. Of course, this becomes -1/32 right there. And the cool thing about the definition of a parabola is that any point on the parabola is the same distance from the directrix as it is to the focus. See, here's this distance right here, which was calculated using the distance formula. No matter where the point xy is on that parabola, these two distances are equal. So another way to derive the equation is to come up with formulas for each of these distances, set them equal to each other, and solve for y, which is what I've done on board 3. The distance from any point xy on the parabola to the directrix, well, the x coordinates are going to be the same, so it's 9 minus y will be the distance from the point to the directrix. The distance to the focus, we have to use the distance formula, the square root of x minus x sub 1, or x minus a -6, quantity squared, plus y plus 7, the quantity squared. So if we set those two distances equal to each other, square them to remove the square root symbol, on the left we get 81 minus 18y plus y squared. Over here I'm going to leave x plus 6, the quantity squared, in that form, but I'll expand y plus 7, the quantity squared, into this perfect square trinomial. The whole key is that the y squareds cancel out. That will happen in general every time you have an up or down opening parabola. The y squareds will cancel out. So if we put the y's over here on the left, we get -32y, because I subtract 14y from both sides. Move this 81, or subtract 81 from both sides, gives me -32. If I divide by -32 every term, I'm back to vertex form. Okay, and that's where that original formula comes from, by setting these distances equal to each other in general. Okay, so hope that helped. If you have any questions, post a comment.